Let's take a little time to talk about concave lenses here. So a concave lens is a lens that focuses light outwards away from a focal point. So if you look in the bottom here, we have 3 lines, 1, 2, and 3 going in, and then when they come out, they're all spreading away as if they had come from the focal point. So they're going straight lines outwards as if they had originated in the focal point. And you can see why, and again there'll be a concept development sheet that connects this, but basically when it goes in on one side of the lens it gets bent, when it goes out on the other side it gets bent again to bend further outward. So what are our rules for convex lenses? Well, a ray parallel to the axis bends as if it had came from the focal point on the same side as the object. And again, these are kind of weird wordings, maybe a bit hard to visualize, but once we sketch it, I think it will make it clear. A ray traveling through the center of the lens will travel straight and not bend. So if it's going through the center, it just goes in a straight line. You don't have to worry about it. And then a ray traveling towards the focal point on the opposite side of the lens will be bent parallel to the axis. This one's the hardest to put into words, but once you see it, again, I hope it'll be clear here. So let's look at an example. So technically, if this was a convex lens, it wouldn't look like a straight line, but because we only care about the center of the lens, I've modeled it as a straight line. But if it was an actual convex lens, it'd be bent kind of outwards like this. Sorry, concave, I don't know why I'm saying convex, concave. And kind of the mnemonic that I use is concave has little caves carved out of the side here. Little openings there. So let's draw an object. Let's say we've got this guy here. So an arrow like that. Now let's go through our 3 examples. So first we have a ray that's going parallel to the axis. And nice and straight. Now this will be bent away, so it's going to be bent as if it had come in a straight line from the focal point. So that focal point, and it goes off like this. Line going through the center just travels right on through. Whoops, that's poor, so we'll sketch that again. These long lines are always hard to draw when I can't sketch them. Let's see. That's looking better. Yeah. Not perfect, but it'll be good enough to get the idea. And then finally a line that travels through the focal point on the same side gets bent parallel. No, sorry, that's completely wrong. That would be for a convex lens. Now, if you're wondering how I saw that, I noticed they were going to intersect, and you shouldn't ever have ray diagrams where 2 of the lines intersect and the 3rd does not. Or rather, if that is going to be the case, they should at least be close. So in that case, I saw a clear intersection was going to happen with the 2 lines I was drawing most recently that wasn't going to intersect the other one, so I knew I had made a mistake. So I should be headed towards the opposite one. So I'll sketch that in. Again, this is getting a little poor. And that will come straight out. So the line that should have gone from the tip of the arrow to this dot, when it hits the lens, it goes straight out. Now what we notice is we don't have these lines intersecting at all, so we're going to have to look at creating a virtual image here. So let's jump over to red. So if my eyeball is over here, and these lights are hitting my eyes, where does my eye think they came from? Well, it thinks this line is nice and easy. It thinks it came from down there. This line's pretty easy. Horizontally, it thinks it came from there. This line's pretty easy. It thinks it came from where it did come from, right here. And those are sloppy, but you see they do intersect, hopefully, or you can at least buy into the fact that if these were all perfectly straight lines, they'd intersect. And we get a little arrow down here. So this is an arrow that's closer to the lens. It's smaller, or it's magnified, shrunk down. It is upright. It's a virtual image because we had to look from the opposite side and imagine where, or our brain had to think where the lines would have come from. And it's upright. It's vertical. So let's look at another example to kind of close this out. Let's say we've got a arrow like so, and this time it's closer to the lens than the focal point. So first we, as always, have our line that's coming parallel. This line gets bent as if it had come from the focal point. So something like that. Then we have our line that's going through the center, which should be something like this. Then we have our line that is going as if it would have gone to the focal point on the other side, which is pretty rough. So I'm going to cheat a little and pop it up here because I think that's about where it actually should have been. And that's just from eyeballing these things and being used to them. So then we notice they don't intersect, so we have to go think about virtual images here. So we got our eye to remind us that we're looking from this side. And where do these lines trace back? Well, we already kind of said this one should have come from the focal point. This one should go straight across. And this one came from where it did come from, and what do you know it? They all intersect to create a virtual image. Whoops. I don't think I can bring that back, so we'll just pop this in. And you can go back in the video to double check, but we basically had something like this and something like this. So our image is closer to the lens, it's shrunk, it's upright, and it's a virtual image, and it's on the same side as the object. So that's the idea behind convex lenses. You can kind of play with those and try them out on the concept development sheet.